Okay, so in this video, I will do this question power of 3. So I accidentally clicked on this practice time and this question open. So I thought I should make a video on it. So that's why I'm making it. So power of 3 is an easy type of question and we have given an integer return true if it is a power of 3. So question is pretty simple. We have to return true if it is a power of 3. Else we have to return false. Yes, that's it. So if n is a power of 3, if their integer exists, okay, n is equals to 3 raised to the power x. Okay, so example 1, see this example 1 if you cannot even understand it now. So if you still do not understand, didn't understand it, see this question, this example, n is equals to 27. Yes, so 27, is it a power of 3? So 3 into 3 into 3, 3 into 3 is 9, and 9 into 3 is 27. That's why 3 cube is 27. So yes, it is a power of 3. So true. 0, so 0 is not a power of 3. You put x anything, put here, put x anything, you will never get 0. 3 raised to the power x will never equal to 0. And again minus 1, any power of anything cannot be equal to minus 1 on negative number. So that's our question, and I'll use a recursive approach here. You can use iterative as well, but I would like to use recursive. So how can I do this? So suppose I have this 3 27 initially, 27. Okay, what if I divide it by 3? 27 by 3. Yes, this will give me what? 9. Okay, now again, if I divide by this 9 by 3, 9 by 3, this will give me what? 3. Now if again I divide this 3 by 3, this will give me 1. And whenever I get 1, means this is the power of 3. See why? So suppose let's take a number which is not a power of 3. Let's take 29 or any other number. Let's take 32. 30. Okay. So I'll do 30 by 3 first. I'll do 30 by 3. So 30 by 3 is what? 30 by 3 is equals to what? 10. Yes. Now I will do 10 by 3. 10 by 3. So it is what? 3 3 is a 9, 3.333. Yes. 3.3. Let's take 3.3 only. Now if I do 3.3 by 3, that will be 1.1. Okay, and 1.1 by 3 again, so it will be less than 0. So see, if it is not 1, then it will always be less than 0, greater than 0 but less than 1. It should be 0 point something something. Okay, we don't care about that. 0 point and like this. Okay, so it would be 0 point something, but it will never be 1 if it is not a power of 3. But it will never go minus 1, never go negative. It will always be greater than 0 and less than 1 if it is not a power. So let me write it here. If not a power, okay, so then if not a power, then 0 to 1 only. If it is a power of 3, then sorry, then 3, then 1, then you will get 1. So we will write recursive code for this. How can we write it? See, I will use this function only is power of 3. I will do what? I will first call this function with, I'm copying this function name, pasting it here, return turn is power of 3 with what? N by 3. I'm calling it with n by 3. And whenever my n is equals to, if n is greater than or less than 1, return false. Yes, or if uh, else if n is equals to 1, return true. This should be our code. And let me see, will this run or not? Let me run it first and then see pending, and see, it is giving me output and it is accepted properly, and let me submit it. So I think this will be submitted and this will give us right output. So see, it is submitting, and see, we got a lead coin. So for our day, and we have completed 1 day streak, so that's good. And that was our code. See, what's that recursive code? Let me explain you first how that recursive code is running. So suppose our function is 3. Yes, Suppose this is a function and we have 26 inside, 27 inside it. So yes, it is a power of 3. Inside this, we will call the same function. We will call the same function is 3. Is 3. Suppose this is the name of function with 27 by 3, that is 9. Okay. Now again, we will call the same function. We will call the same function with like this. I'm doing it here. We will call the same function is 3 with what? Is 3 with 3, 9 by 3. Okay. So again, we call it by 9 by 3. And we have a, see, in recursion, we always have a base case. Without that, if I remove this base case, if n is equals to n, these if and else if conditions, if I remove them, we'll fall into runtime error. By runtime error, maximum call stack will be exceeded. Memory will, all memory will be done, will be occupied by this code. So we don't want that. That's why we always write a base case in recursion. So is 3, this is 3 will call again is 3 and see, now it will call it with 1, and whenever this will become 1, whenever this will become 1, we will return true. And if this, suppose this was not a 20, this was not 27, this was 29, suppose, then we'll call this by 29, or let's say this was 30. 30. 30 is a good number, yes. 30. Then we'll call it with 10. Then we'll call it with 3.3 something, yes. Then we will call it with 1.1, yes. And after that also, now it is not equal to 1. We'll call it with what? We'll call it with 3. So now we'll call it at 1.1 by 3. So it will be 0 point something something something, and that 0 point something is always less than 1. Yes. So if it is less than 1, we will just return false, and this return statement will have false inside it. After that, here it will give me false, false, FAL, L SE, right? So when this will give me false, it will return this false back to this. It will return this false back to this. It will return this back to this, and our answer will be written like this. After final answer, this is 3 will return as final answer. So they all were returning us a function of code. This function was calling this function again, returning this function, and that function is returning this function again with another different value. And after that, we got our final answer. So this was my explanation. If you like it, then it's totally okay. And yeah, that was our code for this question. Thank you so much. This was an easy question and it is accepted totally. Thank you so much.